definition of mental well-being under the context of digital companions, a common architecture of this system-based technical analysis, and we provide an ethical analysis of the systems and a socio-technical evaluation as well. There's typically a lacking of methods and frameworks for doing socio-technical evaluation of digital companions, and we have done some providing some insights into that, how to make a methodology for that. Our methodology is a hybrid search approach, where we looked at related papers on digital companions supporting mental well-being. We combined corpus search with the backward-forward snowballing, using search terms such as digital companion, well-being, artificial intelligence, software design, and some variations of that. We found 67 papers and identified 13 digital companion architectures that we have considered. And we have some inclusion criteria there: English language articles, publications between 14 and 22, and describing mental well-being support applications. Here's a list of applications that we have looked at, and we can see here that typically there is some form of AI technology involved. If there is just if-then rules for a system, natural language processing involved, or some kind of agent architecture, even multi-agent systems. Machine learning also involved in some cases. And we can also see that cognitive theories has been influential for creating the behavior of these systems. Such as the cognitive behavioral therapy is a usual approach for this guiding the behavior of these kind of systems. However, these cognitive theories typically are used to guide this maybe more static behavior of a system, and are not typically used to better understand the human that the system interacts with, to model the mind of the human, and to create this personalized support. So we have seen, these are some of these theories that was identified: motivational interviewing, cognitive theory with behavior therapy, and so on. What we've seen is that there is a need for person profiles, as we call it, for tracking treatment processes, physical, medical, and mental. We define two key profiles there, with a psychological profile that help in personalized plans to track the development, and emotional profile to understanding emotional characteristics for managing, understanding emotions of the individual. And currently there are typically missing this kind of profiles. The emotional profile, we cannot find them in the architecture that we looked at. Only 4 out of 13 had psychological profiles. One thing to note is that the user emotions are typically not considered in mental health interventions from the systems. Another analysis we wanted to make is that by looking at autonomy and social awareness in these systems. And this is a model that's been proposed before that we are utilizing for our purposes, where a system based on its level of autonomy and social awareness could be considered as a tool, an assistant, or a partner, which increasing proactivity and human-like behavior as the partner would have some capabilities of human-like capabilities interaction, while the tool is more reactive. We put these different architectures into these three classes and found 4 of them as a tool. 9 of them we classified as assistant, and we could not find anyone classified as partner. We finally we looked at the ethical aspects of it, see what was stated in the papers regarding how the systems, the ethical considerations. And we can see that in terms of privacy and security, it was typically there. But many of these papers lacked this ethical analysis. And to go on with this analysis, we looked at assessor technical framework for analyzing AI systems, and we tailored it towards digital companions. We have 13 criteria, for instance, respecting fundamental rights of individuals, privacy and data protection, transparency rights, avoiding discrimination, accessibility, education and tutorials, data management, security, open source code, public ownership, legislation and policy, design impact assessment, and open development process. And these can be categorized into 0, that it's not stated at all about this in the architecture, or 2, that it fully complies with this criteria. We looked at 4 chatbots considered state-of-the-art, and commercial chatbots, and Woobot, Replica, Jaina, and Visa. And we did this categorization for each of them based on the knowledge we could find about them in the papers. And we could see here that there are some things that are typically missing in these chatbots, and some things that are typically there. And if we look at combined for all of these chatbots, we could see that privacy and data protection, data management, security, application easy to deactivate, remove, legislation and policy, they are typically there and fully complied in a high manner, while accessibility, educational tutorials, open source code, public ownership, and design impact assessment is typically not there for any of them. We identified some challenges and opportunities. So well-being can be considered a skill that can be improved in tools like the companions can be helpful for that improvement. So there are, despite this, there are some sensitive issues for development, design, and testing. Ethical concerns, commercial projects consider ethical aspects related to testing with humans, but they lack considerations about transparency, and there are no options for users to inquire about and responses typically. Lack of psychological profiles, as I mentioned, the absence of psychological and emotional profiles hinders personalized responses and can lead to tedious interactions as well. Limited clinical evaluation. This system typically lack comprehensive clinical evaluation, making it challenging to assess the impact on individuals' well-being and the therapies they provide. Documentation challenges. They are typically not well compared against each other. And while these psychological models are typically there, they have not been compared to a large extent with other digital companions. The multidisciplinary efforts is required to generate the standards and evaluation testing and protocols for these kind of systems. I finally want to make a note about personalization and standardization that we have identified that well, in the absence of cognitive theory-based tear-find models in digital companions, where these cognitive tiers are typically based on static behavior, but not on the understanding of the individual it interacts with. Implementing such models would allow for more personalized profiles, enabling tailored assistance from these systems. On the other hand, we have standardized profiles that also is required because we have users that interact with multiple systems. And when they change from one system to another, it would be greatly beneficial to have some standardized user models for transferring this these profiles between systems. Of course, this also leads to more challenges regarding data management. So that was my final note. So thank you.
Thank you, Andreas, for this excellent presentation, and very interesting because usually we have several assistants and we don't have a clear overview to see if are they really good or not, or are they iatrogenic for the people. So is there any questions of the public, please? Well, I'd like to ask, you mentioned before the if-then rule-based systems, and that they are not implementing any theory like cognitive conductive therapy or something like that. So do you think a more complex model is needed in order to fully implement such kind of therapy?
Yes, I would say so. So I think it comes in two ways there. We need to understand the context. That's one thing. And I think that many systems absolutely come to there to a large extent. But then we have to understand how does these individuals change? And that comes a challenge. And I think these theories can help with creating such dynamic models for understanding change.
Yeah, I agree. And well, how about ELISA, for example, which was extremely simple, and some people believe that it really helped them. What do you think on the implementation of such simple models?
I think that these simple models absolutely can do some. I think what we come with these simple models is that we generalize absolutely, and there's many guesses in the behavior of the systems, and we lose some control of what the system what kind of consequences it may lead to regarding the individual. So that's, I think, a benefit when to increase the look at more. We need rules. We need rule-based systems, and we need constraints for the systems to really make them safe.
Yeah, I agree. Safety is the main reason. So are there any other questions from the group? Well, if there are not more questions for this work, we thank our speaker. Thank you very much, Andreas, for presenting this work.
Okay.
Well, we have another work. I think you will be presenting as well, if I'm not wrong. This work is called Towards Control in Agents for Human Behavior Change, an Autism Case. So please, Andreas, the same as before, you have 10 minutes and then 5 minutes for questions.
Oh, thank you. So I happen to be the co-author of this paper as well. Let's see.
So the screen is all yours.
Thank you. All right. Hello, everyone. So I'm Andreas Brännström. And done this work with Jean Carlos Nieves on towards control in interactive agents for behavior change. So it has been more increasingly an interest in designing intelligent interactive systems for different purposes in recommender systems, smart homes, autonomous cars, and also increasingly these e-health systems for tasks such as depression management, therapeutic support, social companions such as chatbots, mimicking human-like social traits. In these kind of systems, and I would say a particular example is these e-health systems, where you need personalized interactions, and to give a personalized, person-adapted support. However, typically these systems use generalizations of the users, use statistical methods to characterize users, which create snapshots of human behavior and approximations based on this demographic data that they have provided. In the state of the art, there are a variety of methods for designing agents that can predict behavior of other agents, such as humans. Having an have some history of the interaction, and create a model to predict actions, goals, and so on. A problem with most of these systems, as I previously stated, is that they typically regard static models. So we have statistical models that create that reasons about a context, but this context might change, the human change, and we need to reason about, we need models that are dynamic. So human-aware planning is an area where we design systems that are in a situation, in an environment populated by humans, where the system designs a plan that meets the requirements of the human plan. So it needs to have a concept of what the human goal is and what the human plan to do to reach it, and how these two plans can coexist. And there are many things in the environment that can affect this, such as the things around in the context, and as well as human mental states, emotions, motivations, and so on. They change the human's goals and plans. The human's mind is in constant change, and we need the system to be able to reason forward by considering how the mind will change, so such an emotion, a future emotional state, and backward to reason about what causes this, so what a past emotional state or a past configuration of the environment. I want to present a case study that we did in about children with autism, and it's a virtual training simulation where we wanted this virtual environment to change, adapt the challenge for these children. So the children typically have things that causes stress in this environment, such as people, lights, sounds, and so on. And we wanted this system to be dynamic and be able to change the environment depending on the user's mental state, user's current state of motivation to engage in this activity. So we did a series of knowledge elicitation studies, 2 of them, to identify. We talked with domain experts, experts on autism, and to identify elements of stress in this environment. And we used a theoretical framework to a cognitive theory, a theory of planned behavior, to kind of focus our investigation. We finally wanted to implement different prototypes to evaluate this behavior, and we did that in terms of DLK planning language and based on ASP, also set programming, and we developed this environment in the Unity 3D environment. The theoretical framework here of planned behavior has 3 sets of beliefs that bases a human's motivation: the attitudes, the subjective norm, and the perceived behavioral control that the individual feels in a situation. This leads to a behavior and can, in this way, predict behavior. So this theory has 3 equations that based on what kind of attitudes, beliefs in the environment that has been observed, different beliefs about norms in the environment, and different beliefs about the control elements of the environment. And based on this, we can get an assessment we can get a value on these different classes. But we needed a way to reason about these 3 concepts. So we needed to elicit more about what are these different beliefs, what this part of the environment could cause this. So we did the first study has 5 experts, psychologists, teachers that worked with children with autism. So we did qualitative interviews with them to identify the stress factors. These interviews were coded, transcribed and coded to find different stress factors. We then grouped them up into signs of stress, sources of stress, management of stress, and we later connected that with the theoretical framework to group this up in terms of attitude, subjective norm, and behavioral control. We later related concepts to each other and could match that certain stressors depended on others, and certain management of stress was a way to manage certain stress states. This finally led to an ontology or a mental state model. So based on this, we could identify these behavioral control, attitude, and subjective norm levels based on the humans, what this has been observed in the environment. We could then define rules in terms of semantic web rule language to identify, to reason about this mental state context or what has been observed to get these values of these 3 classes: behavioral control, attitude, and subjective norm. In that way, we could define a mental state model so that this is the one snapshot of the human's mind. We needed now a way to reason about change, how the dynamics of the mind. So we needed another knowledge elicitation study with another set of experts here, and we also been working with autism, and we could identify with interviews with them a set of principles for how to reason about change of motivation. And when condensing these principles, we found these 5 sets: prioritized, push attitude away from a negative state when possible. Principle 2 prioritizes to push subjective norm away from negative state if the attitude at least medium and the behavior control is positive. Principle 3 prioritizes to push behavior control away from a negative state if the attitude or subjective norm is at least medium. And if all three aspects are medium, then prioritize to push A to a positive state. And the aim is to find a state where all of these states are positive. We could define a transition system. A transition system is a set of states, a finite set of states, and actions to change configurations to reach to this transition between states. And based on these three classes, attitude, behavior control, and subjective norm, and values of negative, medium, and positive on each of them, we could define a state space. So this is a motivational state space. And a state, we find something that we call a safe emotional state, where these principles hold, these 5 principles. So this is our motivation transition system or motivation change model. And based on these rules and the ontology, we could identify which of these states that we are in at the moment, depending on the observations. And with this model, we can reason about where should we change, what configuration should we change. We want to reach the positive state. And with this model, we can reason about what action of the system to do next. This can be combined into a general architecture where we have a user interacting with a symbolic layer of the system, getting observations. Maybe it could be some neurosymbolic methods there to identify observations. We have here a mental state ontology or mental state model that identifies the current mental state, the initial mental state that we're in now. And finally, we have a mental state transition system that based on the state we're in, we can reason about where to head next with system actions. And we have the human in the loop. So we have domain experts, system designer that are part of the development of these models and the evaluation for model refinement. In conclusion, we have a formal description of mental states to allow us to analyze the mental dynamics in terms of precise mathematical properties. With this transition system, we can find safety properties that say that it's impossible to purposefully enter an unwanted mental state. This provides controlled system behavior in this kind of systems for behavior change. And we can reason backward and forward in this transition system to reason about causes and to reason about where we want to go. For understanding the system actions and their effects on the mind of the human. There are extensions to be considered in this framework for future work. Temporality, uncertainty. Currently, the rules of the system are deterministic, and we need a way to reason about uncertainty for certain in this kind of applications. All right, thank you very much.
Thank you again, Andreas, for this wonderful presentation again on a different subject. And please, any of you on the audience, please ask a question. Well, I would like to know, you presented a virtual environment in one of the slides for autist children. So I wonder, have you found any difference on interacting with a 3D model and a 2D model, because they are just watching a screen? So I'm not sure if autist children may feel different, may not grasp completely the idea of the scene?
Yeah, so it can of course depend on the individual, how what kind of challenges the individual has and so on. So so far we have only tested with experts. We have not done any studies with autistic children, so I cannot say more about that. How they would perceive the environment, but the experts was positive about the system and could also agree. So we did an evaluation with the experts, and by considering these rules of the system and what kind of changes it provoked in the environment, we could see that most of these experts also agreed with how the system reasoned about these changes. So we feel like we have grasped, we have captured the to some extent the systems, the experts' suggestions of how to reason about motivation. Of course, this it's always tricky with these 3D environments. How realistic should they be, for instance? This can absolutely be an influence the training simulation for an individual. Maybe sometimes we need a more characteristic, cartoony simulation, sometimes some more realistic. And that can also be one thing we can change in the environment dynamically based on a person's challenges and what they want to practice with.
Yeah. I see. Well, there are lots of more questions, I'm afraid, but we have run out of time. So thank you again, Andreas, for this work. And well, I'm sure maybe I will email you for more questions. Thank you very much.
Absolutely. Thank you.
Thank you. Well, now we have the next work. It's called Metatron, a methodology for automatic generation of short fiction stories with cognitive-oriented techniques. So I will ask one of the authors, Brian Herrera Gonzalez, to present this work. Please, you can start sharing your screen, Brian. And remember, you have 10 minutes for presenting, and then we will have 5 minutes for questions and discussions.
Okay, thank you.
Thank you, Brian.
Thank you.
Go ahead. The screen is all yours.
Thank you again. Well, I'm Brian Herrera, and I'll present this work. Please allow me. Okay. Okay. I'm Brian Herrera, and along with Dr. Eram Calvo and Dr. Alexander Gelbuk, we work on this paper called Metatron, a methodology for automatic generation of short fiction stories with cognitive-oriented techniques. And, well, we'll start by defining a story. It can be either an account of imaginary or real people and events told for entertainment, or an account of past events in someone's life or in the evolution of something. In this case, a specific case of story is the human story, so the history. And our motivation is based also in this phrase. The universe is made of stories, not of atoms. Written by Will Rukeyser in The Speed of Darkness. And that is because the majority of knowledge we have is about not standalone elements, standalone events, but stories built around them. So also we have this question, can a computer be creative? We think that tasks like automatic story generation could help us to get an answer. We based our work in narratology because it seeks to model narrative representations, and based on entertainment, we have these 5 variables. Cohesion, it means also fluency, and it's at level of discourse. Coherence, that is correct linking of events. That means it works not a discourse or writing level, but an event level. Consistency, also the respect of previous events written or about the word logic. Novelty, stories never seen before, and interestingness. We want to evoke emotions in the reader. About the evaluation of these 5 metrics, we have, for example, for novelty, automatic metrics like distinction n and repetition n. These are metrics based on the percentage of engrams in the stories or in some just one story. For cohesion, coherence, and consistency, we can evaluate it in an automatic way with perplexity, but also in a manual way for coherence and consistency, and survey for 3 of them. And also emotion is something that interests us really much. And there are a lot of ways to measure emotion, like fMRI, galvanic skin response, blood pressure, facial expressions, heart rate. But in this case, in particular, we follow the same as other works. We propose a survey in an experience sampling way. So our methodology is basically this 4 sub-process. The main process start, and with a knowledge database, we get matrices and phrases that give us the outline of our short story. Then we use a narrative interpolation for obtaining a full short story and a dramatic situation frame. And then we have 2 sub-processes to obtain an image generation and an audio generation. Okay. For the outline generation, the main core of this is obtaining the begin, climax, and output phrases. And so the process start, and we have a blank AVM generation, means attribute value matrix. Then we fill it in a basic way. That means in a random way, we introduce knowledge in the matrices to perform a new story. Then we have a random dramatic situation, but this dramatic situation will be linked to the situations before them. And we obtain the matrices of this process, and then we use a model, for example, a GPT-4 model with few-shot learning for obtaining the VCO phrase. For this outline generation, we use the 36 dramatic situations, and this book was written by Georges Pulty, but it's really ancient idea. For example, from Carlo Guzzi, from Goethe, and Mike Figgis, we have 36 dramatic situations, and they seek to model all the possible dramatic situations within 36 possibilities. An example of these situations is, for example, SD5, pursuit. It have the main objects, fugitive and punishment, and it's contrary to SD1, and it could be possible outcome from SD3 and SD4. As a note, it aims to empathize with the fugitive. An example of our attribute value matrix is this. It has the dramatic situation, P, the time T, in which that occurs, who, what, where, whom are making this action, the tool, why, another dramatic situation. If the matrix is, or the phrase will be negative, and it happens in the final cut. Also, we propose the motion in a tuple of type and intensity using automatic emotion regulation. And well, in this case, this will be all for the outline generation. Then we have the narrative interpolation, in which we have this sub-process. It receives the alpha phrase and the omega phrase. And then, for example, the fictional generator uses the alpha phrase, in other words, the left context, for writing n-candidate phrases, and then uses the coherent ranker. The coherent ranker also have this left context, the alpha phrase, and the right context, the omega phrase, for choosing which is the best phrase from the n-candidate phrases. And then we have a process for generating its matrix, its attribute value matrix. And then we have all our matrices updated and also the story updated because of the new phrase. For our fictional generator, we only use the left context. So we propose an autoregressive model, large language model, as GPT-2 or the family of GPT. And for the coherent ranker, we proposed a masked language model for getting this two-way context. An example of this subprocess, for example, we have B, C, and O. Then we have just one phase. Then it introduces BY and CY between them. And with another phase, we have now 9 phrases, BX, BC, CX, CC. And then, well, and so a full short story with 9 phrases. Okay, about the image generation and audio generation, we make use of latent space models or foundation models using these both or different type of inputs. For example, in this case of clip, where they use a text encoder and an image encoder for making a latent space in order to have a way to go from one input to another. And so, for example, we'll use a text-to-image model with a specific technique for retaining the context and making a cover, and also a specific text-to-image foundation model in order to make this immersion with the main keywords for this story. Okay, so for the methodology that will be all, I'd like to talk about why neurosymbolic approach is the approach we are following. We want the best of both worlds because the GPT family has been known for increasing, for example, the variables we want to evaluate. But any step is harder to complete, and most of these variables are well done with symbolic approaches. Also, we present cognitive-oriented techniques like automatic emotion regulation and immersion. The automatic emotion regulation is mainly on the symbolic process for generating the matrices and the phrases, the main phrases from the outline. And immersion is with the OST and the cover generation. It's also limited resources oriented. We do not want to build a extra large model, extra large new model, or fine tune an extra large model. And also we propose within these matrices a framework for generating longer stories. Well, that will be all in this case. Thank you for your attention.
Thank you so much, Brian, for your presentation. If someone in the room have any question, this is the moment, please. Okay, Brian, we don't have question about your presentation.
Sorry,
Ah.
I do have
Ah,
a question.
thank you so much.
I was writing. Sorry, Brian, I wasn't in the beginning. I don't know if you mentioned that. Can you hear me?
Yeah, sure.
My question here is, how can you compare your work with the pure generation made by GPT-4, for example?
Yeah, we have 5 main variables or metrics, and the majority of works done in this area measure these 5. The same, we will measure in the automatic metrics, we will measure distinction n, repetition n, and it's the same that the percentage of n-grams in the same story and among stories. Also perplexity, it is validated that the lesser the perplexity, the greater the cohesion, the coherence, and the consistency. But our main manual evaluation will be a survey, and known also as experience sampling.
All right, thank you. Thank you very much for your presentation.
Thank you, Fer.
We have another question in the chat. What about the initial question? If a computer can be creative?
Well, we don't know. It's like a really hard question. We think that this kind of tasks could help us to get an answer or to approximate us a bit to that answer. But for sure, we do not know yet.
Okay, thank you.
Thank you. Thank you for your presentation. And the next presentation is, we have a change in the program. The first is Linen, Emotional Resources Inference Algorithm based on 1D ComNets. Present Marco A. Cardoso Moreno, Juan Eduardo Luján, Iram Calvo, and Cornelio Yáñez Márquez. If someone in the room?
Here, Marco Cardoso. Thank you very much.
Okay, you can present, please.
Yeah, sure. So, can you see my presentation?
Yes.
Okay.
You have 10 minutes to your presentation and 5 to question and answer.
Yeah, thank you very much. Okay, so thank you everybody in the room for being here. As I already said, my name is Marco Antonio Cardoso Moreno, and I'm going to present the work that I've developed with my colleagues Juan Eduardo Luján Garcia, Dr. Iram Calvo, and Dr. Cornelio Yáñez Márquez. And well, the name of our paper is ELINA, Emotion Low Resources Inference Algorithm based on 1D ComNets. Okay, so first of all, a little bit of the agenda for today. We will have an introduction, then we will discuss our hypothesis for the task. We will present some related works as well as our methods and materials. Then we will follow with our proposal, our models. And in the last part of the presentation, we will talk about our results as well as conclusions and future work. So, okay. In this task, in our research, we were principally concerned with emotion recognition for human-computer interaction systems. So why it is important to be able to recognize emotions? Well, there are 2 main applications, although there exist many more. One of them can be with online learning systems where the teacher or the system might be able to understand the emotional state of the student in order to provide better feedback. And this should improve the learning process. Okay, another important area of application is psychological diagnosis, where the therapist would be able to better understand the emotional state of the patient. So, sorry. So the therapist might be able to better understand the emotional state of the patient in order to give a better diagnosis and to provide better treatment. With this in mind, we need to define what are emotions under the context that we are dealing with. For that, we have this quote from Motley and their colleagues from the year 2006, in which they stated that emotions encompass a complex interplay of physiological and psychological responses, manifesting in both muscular and motor expressions, as well as neurological functions. So, well, let me start now with our introduction. So, as I already stated, we are dealing with human-computer interaction systems. And, well, we also stated that we are dealing with emotion recognition. And how can we recognize these emotions? For that, we need to sample some biological signals. From that, for some examples of this, of how can we retrieve those signals are electroencephalogram or EEG, electrocardiogram or ECG, as well as galvanic skin response or GSR. Once we have all these signals, it is common practice to use machine learning algorithms for the task of emotion recognition. With this in mind, our hypothesis is that it is able to it would be possible to analyze biosignals obtained from sensors such as ECG and GSR and classify them into different emotions using small deep learning models. Now, let me start with the related works. First of all, we have the JAD dataset. This is, in fact, the dataset that we decided to work with. Here, I'm only going to talk about the baseline model that they developed, which was a convolutional neural network followed by an LSTM cell. So they had 3 convolutional layers. And at the end of the model, they had an LSTM cell. As validation method, they used holdout validation, and they achieved an accuracy of 66%. The other work that has that deals with this dataset is the one from Malam and their colleagues. This is from this year, 2023. So they used 3 different models: random forest, support vector machines, and decision trees. And we can see here that they achieved accuracies of 98 and 99%. But it is important to emphasize that their validation method is was 5-fold cross-validation, and this can come with some issues because with these kind of partitions, what happens is that at least for one user in each iteration, their data might be found on both the training and testing sets, and this might lead to data leakage. Now, let me talk about our materials and methods. So as I already stated, we worked with the JAD dataset. And well, this dataset contains signals from 25 subjects. With these subjects, they were presented to movie clips for about 39 seconds in order to elicit in them 7 different emotions. These emotions were happy, sad, neutral, surprise, disgust, anger, and fear. In this dataset, we have 2 subsets, one that is called single modal, and we later refer to it as dataset A. It consists on signals from 13 subjects, and it only has ECG signals. And we have a counterpart, which is a multimodal dataset. It has information from 12 subjects, but in this case, we have ECG and GSR signals. As a validation method, we used a leave one out cross validation approach, but in this point, the instances that we are leaving out for testing is the whole data for each subject. So in each iteration, we separate the data, all the data from one subject, use it as testing, and the rest of the subjects were used as training, which with this, we ensure that there is no data leakage in our results. For our proposal, we proposed two different preprocessing pipelines, sorry. The first of them, preprocessing A, consists of filtering with a backward filter, a passband filter. Then we drop the first 5 seconds of the signal, since in the dataset it is stated that these signals do not contain any stimulus applied to the user, to the subject, so it is considered base noise. In the following step, this base noise was used to further clean our signals. Later, we perform a min-max normalization, and lastly, a decimation with factor of 2, so we reduce the size of our signals by half. In our preprocessing pipeline B, we as well drop the first 5 seconds of the signals, but instead of filtering, what we did is to perform a decomposition of the signal with empirical mode decomposition. So in the figure on the right, you can see at the top of the figure, we have the almost the original signal, and bottom of it, we have several IMFs, which contain different mode of oscillation of these signals. So these IMFs are the decomposition of the signal. Once we did this decomposition, we applied to each one of these bands a min-max normalization. Then we can talk about our models. Here we are going to present two models. The first one, well, both of them are 1D convolutional neural networks. The first one, we call it BEC1D. And here we can see that we have 4 combos of convolution followed by a max pooling. And after all these combos, we just flatten the tensor. And you can see that we do not have a multilayer perceptron at the end. So this flattened tensor is directly passed to the softmax classifier. Now, here we present the ELINA model, which is the one that gives name to our paper. It is also a 1D convolutional neural network. This one is used mainly with the EMD decomposition preprocessing. And as input, it receives the concatenation of both the ECG and GSR channels or decomposed signals, but then we bifurcate them. So we have independent layers, each one of them learning and processing in each kind of signal from different sensors. Once we process this first stage, we concatenate the outputs of both convolutional layers, and then this output passes for two convolutional and max pooling combos. And at the end as well, we just flatten the tensor and pass it to the softmax classifier. Now let me talk a little bit about our results. Here we present the results for the ELINA model with the EMD preprocessing pipeline and leave one out cross-validation. The main point that is important to highlight here is that if you can see that for most of the subjects, we already achieved accuracy, precisions, and F1 scores of 100%. And on average, we can see that accuracy and precision, we achieve 98%, while an F1 score of 97%. In this following table, we present a more comprehensive view of our experiments. So as I already stated, we have 2 subsets of the JAD dataset, one A with 13 subjects and only ECG signals, dataset B with 12 subjects, and here we perform single model experiments with only GSR, as well as multimodal experiments with ECG and GSR. And at the end, we created a new dataset that is the extension of both A and B datasets, but only with ECG signals. And from that, we can see that overall, the best model and the best preprocessing pipeline were ELINA and EMD respectively. And the results are the ones that I presented in the previous slide. So 98% on accuracy as well as in precision, and an F1 score of almost 98 as well. Now for our conclusions and future work. Well, we can first see that ECG alone does not provide a good representation of a physiological response of people's emotions. On the other hand, GSR appears to be a better representation of this body response, so it is more useful for the emotion recognition task. Well, we already saw that both of our models were able to classify these biosignals with a proper preprocessing and achieve great results. But it's important to highlight that the ELINA model, the one that bifurcates the signals in order to analyze independently each kind of sensor, and in conjunction with the empirical model decomposition preprocessing, is the one that yielded best results. And well, for future work, what we intend to do is to try our models to test them with other datasets focused on emotion recognitions. This in order to test the generalization capabilities of these proposals. And well, for my part, that's all. Here you can see our references.
Thank you so much for your presentation, Marco. If someone has a question, they can open the microphone or write via chat. Dr. Iram?
Yes, I don't know if you hear me well.
Yes.
Okay, so I'd like to ask if do you think that a multimodality is necessary to achieve those high numbers, or it can be achieved just by using other signs independently?
Sorry, I didn't hear clearly, so can you repeat the question? Sorry.
Do you think that multimodality is necessary in order to process these assignments and achieve those numbers?
Yeah, I think that multimodality is, it might be not necessary at all. For example, in this table for dataset B, we see that with plain GSR signals in a single modal configuration, we already achieved great performance with 95 and 96% in our metrics. But we saw that when we work in a multimodal way, even if we already have a kind of sensor that yields great results, it can be improved a little bit further. So, for example, I think it depends on the application, but in my particular opinion, I think that, for example, in psychological diagnosis, it would be better to work with multimodal configurations, since, well, mental health is a very important issue and we would like to provide the best help possible.
Okay.
We have other question. What could be an explanation of why if the extended subset, the M doesn't provide the best results?
Okay, well, here an explanation for this might be that biosignals in general are not very stable, in the sense that the behavior of our body's response can change from session to session. And in fact, well, in the dataset, they explained that, well, they were kind of different experiments and different sessions for subjects A and B, well, from subjects from set A and set B. So this might lead to a little bit of noise in our results. And the problem with EMD is that it kind of separates the signal into different frequency bands. So the problem here is that for some subjects, the more representative band might be different from others. So that's why maybe this signal decomposition was not a good fit for the extended version.
Okay, Marco, thank you so much for your presentation. And our next presentation is Modeling the Depressed Mind and Artificial Intelligence Approach to the Big Cognitive Trait by Cesar Macias, Miguel Soto, Marco Cardoso Moreno, and Iram Calvo. Is someone in the room?
Yes, just a moment, please.
Okay. You can start pressing. You have 10 minutes to your presentation and 5 minutes to question and answers.
Yep, thank you. Can you see my presentation?
Yes.
Okay, so I'm going to present the work that developed by me and my colleagues Miguel Soto, Marco Cardoso Moreno, and Iram Calvo. The work is entitled Modeling the Depressive Mind. Sorry. And here is a little bit of a resume of what we are going to see today. First, a little bit of the problem statement, then an introduction, the state of the art, methodology, experiments, results, a comparison against the state of the art, and discussion on future work. So first of all, what gave us the motivation to work with depression is that it affects a lot of people in the world, and it is potentially fatal for people's wellness. Also, it can affect the way the brain works in the structural way and the functional way. So something a phrase that our colleagues and I like take into account is a model designed to aid in the early detection of depression can guide individuals to take appropriate actions in response. So that's something that gave us the motivation to work with this. Okay. To approach to the depression, there are like several psychological orientations. One of both of the most studied and with the most scientific work behind is the cognitive behavioral therapy and the interpersonal therapy. But in this work, we made use of the cognitive behavioral therapy that derives from the Beck's cognitive theory. Okay, so what's Beck's cognitive theory for depression? It's like in a synthesis, the most negative thoughts you have, the most pronounced the experience of how you would experience the depression. That's how I can synthesize the theory, but it is like very complex and so this is the Beck's cognitive theory that he says that we can have negative views about ourselves, about the world, and about the future. And if we start like having negative thoughts about maybe the world, it is like very probable to have negative thoughts about ourselves or about the future, and that could develop like to a more profound or like a depression, like a worse state of depression. I don't know how to say this. I'm not like an expert in psychology, but that's how we interpret the cognitive triad proposed by Beck. And here is the related work in the state of the art. I should say that this is like a very recent work because there were no datasets available to work with. So the first work developed by Jer and his colleagues is where they developed the dataset. So in this work, they proposed a dataset, then they made some experiments with machine learning and deep learning models. And in a second trial, in a second work, he and his colleague Patil proposed new deep learning models to try to overpass their results. Okay, so for the methodology, just a little bit of the insights of the corpus. The corpus is divided into 6 classes: self-negative, self-positive, world negative, world positive, the ones you can observe here. And the authors of the corpus proposed to divide the main task, that is the aspect sentiment classification, into 2 subtasks. That is, first, you identify the aspect, that is what you're talking about, if you're talking about yourself, the world, or the future, and then identify if the text is expressing like positive or negative sentiments. So then you join both of these models, and then you finally can make predictions over the aspect sentiment classification, that is the 6 classes. Okay, so a little bit of how we preprocessed our text. Well, the corpus text is like, we removed the line breaks, then we lowercase them, removed the apostrophes, then we also removed the punctuation, and with the repeated characters, that this is when a word contains a character that repeats more than twice. For example, in a word hello with like 5 O's in the end, we crop the repetition of the O's only to 2 apparitions in the word. And finally, we removed the alphanumeric words, because this is like another task to solve, that is to solve the lead speaking. So we prefer to remove these words, but in a future work we're going to try to take into account this lead speaking. For the methodology, we proposed 4 machine learning models, that is SVM, logistic regression, decision trees, and random forests. And for the deep learning approach, we fine-tuned a BERT model. In this case, we used the BERT based on case model. And then for our experiments, we derived into 2 approaches. The first one is the aspect sentiment approach, that this is the approach proposed by the authors in their original works. And for this approach, we try with 2 sets of experiments. The second set was to try to obtain better performance from our models compared with our first set. And same for the second approach, that in this case, we proposed a multi-class approach, that is to train over the dataset with the 6 classes, and not to first detect aspect, then sentiment, and then join them. The second approach is go and try with all the classes, no? Okay, so here are our results for the aspect identification task. This is the first task proposed by the authors, and in this case, as you can see, for our first set of experiments, we propose like the basic preprocessing that which I explained to you in previous slides. And a part of that basic preprocessing, we tried removing the stop words and to lemmatize the text. As you can see here, we obtained very good results with basic preprocessing. When we remove the stop words, the models fail a little bit. And with the lemmatization, there was not such a problem as with the removing of the stop words. But from this set of experiments, we observed that the SVMs and the logistic regression were like the best models. So then we performed a second set of experiments with the CVM and the logistic regression. I should mention that in this set, the feature vector was reduced using the minimum document frequency and the maximum document frequency. In this case, the minimum document frequency was 3 and the maximum document frequency was 0.9. We used the TF-IDF vectorizer from scikit-learn. And as you can see, the results were very good, even compared to the ones with no reduction in the feature vectors. But in the end, our BERT model was best. So then for our sentiment identification task, the same experiments. But in this case, in the second set of experiments for the reduction of the characteristics in the feature vectors, we used a minimum document frequency of 3, but in this case the maximum document frequency was 0.17, so the reduction was like big. We made a big reduction to the feature vectors, and even with that reduction, our models obtained a little bit best results than the ones with no reduction on the feature vectors. But in the end, the BERT model, again with the fine tuning, was best. Here is when we joined both models from the aspect and from the sentiment tasks. And in this case, this is a machine learning aspect sentiment ensemble. Both of the models are CVMs, and we obtained an 83 of accuracy, and with the BERT model, a 93 of accuracy, and our precision, recall, and score 2. So for the second approach, that is the direct multi-class classification, again, the same experiments for the set 1. We fine-tuned a BERT over the complete corpus. And for set 2, we proposed an ensemble of support vector machines. In this case, we used 3 support vector machines, one to differentiate between self-negative, self-positive, and the others. The other one for world and the others, and the other one for future and the others. So we balanced we created some subsets and balanced them with data from all the other subsets. And we obtained like good results, but not as good as with the direct training over the corpus. But again, our BERT fine-tuning was best. Here are the confusion matrices for both of our best models from both of the approaches proposed, one for the aspect sentiment and one for the multi-class scenario. So as you can see, the results are not far from each other, but the first approach is just a little bit better. So here is a comparison against the state of the art. For the aspect identification task, you can see that our fine-tuning of BERT was the best amongst the other proposed models, even from the deep learning proposed models in the state of the art. Then from the sentiment classification task, again, in this case, you can see that the BERT model outperformed the other models. And that's why in the end, when we assembled both of the models, we obtained a 93% of accuracy in our metrics. And again, we overpassed the final classification task, that is the aspect sentiment with the 6 classes. And you can observe here something that we have, like we try to do every time we like take a new NLP task, that is to try to like get the same performance as the deep learning models with machine learning models. And we were not far from the results obtained in the state-of-the-art with the deep learning models. But when we trained our BERT with the corpus, the results were outperform the other models. And here in blue, you can see the multi-class scenario, that both of these results are not far from each other. So as conclusion, we can say that machine learning are still suitable for classifying text sequences in comparison with the deep learning models proposed in the state-of-the-art. The large language model we introduced to address this task demonstrated superior performance. The novel multi-class approach presented in this study demonstrates the potential for achieving favorable outcomes as well. And for future work, we will conduct a linguistic analysis of the corpus with the aim of visualizing how individuals exhibit early-stage depression tend to express themselves in writing. And that's all. Thank you for your attention. If you have any questions.
Thank you so much for your presentation, Cesar. If someone in the room have a question. Okay, I have a question for you. Why do you think that the multi-class approach working well?
Well, that was something that the authors of the original work didn't try. But when we perform our first experiments over the 6 classes, we observed that when the models were trained, a little bit of confusion was made between separating the aspects. But that confusion was not enough to affect the models in the way that their performance was like very bad. So that's why we continue with the multi-class scenario. I think that the dataset is like it's the balance of the classes is like, they are not like very far from each other. And that's something that helped us train like a very good model to perform the multi-class task.
Okay. Other question. I'm sorry. Do the author who realized the dataset mention the age of the people who wrote the text?
No, just the text. The dataset contains just the text and the tag, the class. But there were no mention for the age or like genders or something like that. Not.
Okay, thank you very much for your questions. If there are no more questions, then let's thank our speaker. Thank you very much, Cesar.
Thank you very much.
And now let me present the next work we are reading. The next work is called Classifications of Songs in Spanish with LLMs, Analysis of the Construction of a Dataset through Classification by María Alcántara, Omar García Vázquez, Giancarlo and Grigori Sidorov. Please go ahead and start sharing your screens. Very good. So the screen is all yours.
Okay, thank you so much. Thank you everything for being in the room. We're going to present our work named Classification of Songs in Spanish with LLMs, Analysis of the Construction of a Dataset through Classification. This paper was made in collaboration with Omar Garcia, Iram Calvo, and Grigori Sidorov, and me, Tania Alcántara. Well, I would like to start talking about the feelings. I would like to say a bit disclaimer. This paper, this work has made in August 2019, and it was increased according to the change of the music in the last years. No, well, I would like to speak about the feelings. The feelings or emotions is complex situation and chemical response in the brain. No, something can produce emotion. For example, when we can see a picture or lyric and lyric music, become a master in turning spectrum of feeling in our brain. No, but explain specifically in the feelings. Can you change the slide? Thank you. Can music convey feelings? Yes, the music has the ability to activate pleasure centers in the brain, but through audio and lyrics. These lyrics are important as the music itself, because even if not noticing the song, the lyrics by themselves transmit the vibe of the feeling associated with it is so very important to know how the fragment of song can change between the positive, negative, or neutral, depend of the sentiment, or depend of the feeling. So during this study, we realized that the Spanish is not the same in all the songs. No, we realized that the culturism, regional expression, levels of formative, disminutive, argumentative, and intonation in the words are different, and these words change, and it's most complicated because one word take most of one of meanings. No, for example, in this part for our image, in Nahuatl, Chile is Chile. No, in Mayan, cocoa is coco, and in Mexican slang, chido is cool. No, it's different, and this is a principal thing that we realize in our study. No. To this work, we use two data sets. No, the first data set is named Textos de Canciones en Español. This was developed in Centro de Investigación en Computación in the laboratory, in the Natural Language Processing Laboratory. This set is made with 91 songs, including bachata, pop, ballads, rock. This is the distribution of our data set. It's on balance. In the the sentiment is 6.76%. And this is the smallest of the data set, but it's very interesting for something. The length of the phrases are bigger. It has different variety in genders, and it's filled manually. I would like to present a bit extract of the data set. Both data sets that we present in this presentation are private. So this is a bit of extract. You can see that the most cases that the idea shows in the lyrics are complete.
So the second dataset is Textos de Canciones en Español Mexicano, versión 1. The dataset was created by the Computational Cognitive Sciences Lab, and it was built with 200 songs. The genres are banda, pop, regional mexicano, rock, and cumbia. This dataset is distributed like this. Neutral has 1,574 sentences and represents the 34.56%. The positive has 1,368 sentences and represents the 30.3%, 30.03%, and the negative 1,613 sentences and represents the 35.41%. This second dataset is bigger than the other one, and it has only Mexican songs. Even when cumbia is not a Mexican genre, There are many Mexican singers of this genre. This is an extract of the second dataset, and you can see that we have a genre column that can lead to a different task, like genre identification or hate speech by genre, and so on. However, even though competitive results were achieved in previous experiments, we observed the following things. Short phrases. Dataset 2 was made using an algorithm where each row corresponds to a sentence of a song, unlike dataset 1, which was done manually and the ideas were completed, and even sentences were joined for the same row. Less information. The information to classify with each dataset is poorer than in other tasks. Hence, it's necessary to combine them to achieve better results. For the above, it is proposed to perform a union of the two datasets to increase the advantages of each one. The dataset was alternated one with another to generate an organic dataset, and when diving them, they are not biased towards a single set, since both datasets were adjusted to have exactly the same columns, labels, and increasing the phrase length by 30% of the fragments belonging to the dataset 2, where this is the homologous from the new dataset. We can see here the comparison of distributions. The first graph is from the dataset 1, and the second graph is from the dataset 2. The third graph is the most interesting because it's the union of the two datasets. We can notice that the unbalancing has been resolved by this union. We perform a process to the first two datasets, doing replacements like numeric quantities, contractions, and mathematical symbols by descriptions. And some remotions like apostrophes, line breaks, parentheses, and white spaces. The preprocessing in this part is not necessary. The main goal here is to allow the model to effectively infer and understand the context presented in the song. So why use LLMs? We select BERT-based, Roberta-based, and Distal BERT-based, but with multilingual case. And in the first place, the resource efficiency. It is designed to work with a wide variety of languages rather than having a separate model for each language. Language representations, shared knowledge between the languages that were trained, and take advantages to improve the performance in another language. And better performance. The performance may vary depending on the language that's being used. We decided to use 3 models, like I said, and there are these are some of the hyperparameters that we used for this task, but there are many more that we are not putting here. So these are the results comparing the datasets by their own and using the union. The first 2 columns were presented in another paper, and that is why we are comparing this work with basically ourselves, because we are so much above from other works from the state of the art. Finally, we can see that the union has a good impact on the metrics, and we can assume that increasing even more the size of the corpus can be good for the metrics and can prevent even more the overfitting problem. So what are the conclusions? The conclusion are that utilizing large language models proves to be a valuable tool for identifying contextual clues that determine the polarity of fragments. Second, data preprocessing coupled with prior classification analysis yields superior results and enhances model generalization. And finally, the consolidation of the datasets is presented as an advantage to counteract the individual disadvantages, which contributes to an overall improvement in the performance of the models. So that's all. Thank you for your attention. And if you have any questions, we will answer gladly.
Thank you very much, Omar. So an applause for your presentation. And if there is someone in the room that has any question, please you can ask now. Okay, I have a question. In the case of Mexican songs, have you identified a genre that has more particularities? Like, for example, I think we all think that reggaeton is the most impulsive or sexist or something like that. Were you able to measure this?
We measured that, we noticed that Mexican songs are one of the most used nowadays in all Latin America. So we labeled these fragments with 3 different people, and we are focusing to label all of the rest of the data set with the help of 3 people more and like 3 different models. So that's it.
I see. Thank you very much. So someone else has a question? And how about the data set? Have you planned to make it public?
I didn't hear the question.
Do you plan to make this data set open to the public?
I would like to respond this question. Yes, I would like to public our data set, but it is the version 1. We develop a bigger version, and maybe middle of the next year we can publish all the data set, because this first version only we have 200 songs, and the large version contain 2,000 songs to classify, and we consider include gender and other popular music in the months can revolution can include in our new data set.
Okay, thank you very much. I think this work can it can be used in many ways to know more about Mexican culture and how it expresses through songs. Thank you very much for this excellent presentation. And now finally, we have our final presentation, which is called Horizontal Gene Transference Identification by means of anomaly detection and natural language-inspired interpretable embeddings by Victor Lomas Barri, Michelle Reyes, and Antonio Nevi. So please, can you start sharing your screen, please?
Hi, hello.
Hello.
Can you hear me properly? Is the audio quality good enough?
I think your microphone is like set to a very high level, so it sounds distorted.
Just a moment, please. I'm trying to fix it.
Hello, Antonio. Now we can see you.
I'm trying to log in with my phone to improve the sound quality.
Yeah, or maybe if you use the microphone of the laptop, maybe we can hear you better.
The problem is my microphone, my laptop.
You can try to switch it maybe on the little arrow next to the microphone and choose a different microphone. Maybe that helps.
I will try that. Just
We are starting a second session.
hello.
Hello.
Can you hear me now?
Now you're muted.
Can you hear me now?
Oh, much better. Yeah, that's it.
Excellent,
Good.
excellent. Yeah, it finally worked. I was trying to share my screen, but I wasn't allowed because of some permissions. So
yeah, because there was
now,
the previous one. Yeah, let's try.
Something happened. My laptop frozen. This is a nightmare. I'm very sorry. Laptop just frozen. I'm going to share it from my phone. So just a moment. I'm very, very sorry about this. I'm going to share. I haven't done this, never done this in my phone here, but I don't know what happened. Well, in the meantime, I don't want to waste anybody's time. I'm restarting my laptop, but as I was saying, I don't want to waste anybody's time. Can you hear me? Can you still hear me?
Yes, very well.
Thank you. And can you see me?
We can see you twice.
My laptop just died. I don't know what happened. I'm going to try to share my presentation from my phone. Anyway, it won't take long. But the whole idea of what I'm trying to present here is the application of an unsupervised method to detect some genes that are relevant within an organism. So I have here my presentation here. Just let me try to share it with. Where can I do that? Anyway, so the whole idea, my laptop is back, so I will be able to connect in just a moment. I'm very sorry. I'm going to run to speed up, so I won't take much more time here. So I'm again logging in, and here I should be there. You should be able to see me in any moment now. I'm trying to connect from my laptop. If you can give me access, then I will be back online. Finally. Oh, I'm very, very sorry. I promised I will rush, so you don't have to give extra time or whatever. So I'm going to share my screen. Let's see if I have more. Probably you are looking at my screen now.
Not yet, but it started. Yes, now we can see it.
So this is what I'm going to talk about. The whole idea is that some organisms have in their genomic material some peculiarities. So the vast majority of organisms, including us, we inherit genetic material from our ancestors. So what I'm depicting here is precisely that. This organism inherited its genes from an ancestor. Sometimes it can be more than one ancestor. Related organism donates some of its genetic material to this organism. So the first phenomena is called vertical gene transference, in which our ancestors donate their material to us. But the second method, the second phenomena, is called horizontal gene transference. The later is quite
important, as I'm going to depict in a couple of slides. But the whole idea is that an organism, a given organism, may present genes inherited from its ancestor or ancestors, but also this same organism may present in its genome some genes that are coming from a completely unrelated organism, even an organism from a different species. So the identification of this horizontal gene transference is rather important for at least two reasons. The first one is that biologists would like to have a better idea of the tree of life, which is depicted to the left in this image. And as you can see, there are horizontal links indicating that some organism was acquiring genes from an unrelated organism. And the second reason why the detection of horizontal gene transference is relevant is because horizontal gene transference is one of the main mechanisms behind drug resistance or antimicrobial resistance. So this is a rather serious problem in public health. An organism may become resistant to an antibiotic because this organism inherited some genes from a different organism that was already resistant to the antibiotics. So that is a concern for medicine, public health, because, well, we would like to identify segments in the genome that were obtained by this process of horizontal gene transference. And as you can see in this image, some genes are acquired by vertical gene transference, which is the usual or more frequent mechanism, and some genes might be acquired by horizontal transference. So the whole idea is that we are that I'm presenting here is that we applied unsupervised learning to try to detect horizontal gene material, and we relied we put our efforts in something called anomaly detection. So if you observe this image, you might detect that there are 2 points that look quite different. Those 2 points I'm referring to are in fact the blue ones. And since we in this example are very lucky to know the generative function, this is a Fibonacci spiral. Since we know this function, that the function that generates these red points, we are able to more or less easily detect that these two do not fulfill the description of the generative function, the Fibonacci spiral. So in this sense, it is straightforward to detect anomalies. But in general, we don't know that generative function. We have to more or less approximate it by some other methods. The whole idea is that an anomaly is a vector or an instance that does not resemble the rest of the vectors under analysis. The basic idea is the vast majority of vectors are generated by a given mechanism, and some of the anomalies are generated by a completely different mechanism. So there are two basic distributions, and the whole idea of anomaly detection is to try to identify those vectors that are generated by a different distribution. Again, we don't know those generative functions or distributions. We have to approximate them. One possibility is to apply something called isolation forest. This is an algorithm to detect anomalies. It's quite straightforward. The whole idea is to isolate a vector from the rest by means of decision trees. So more or less, in this example, we can isolate this vector, the one in orange, by deciding by using or relying in lines, hyperplanes that separate a vector from the rest. So basically, in an iterative process, a random process, we basically need on average only 4 surfaces to isolate this vector from the rest. On the other hand, the blue vector here requires more decisions to be isolated. A vector is isolated when no other vector is in the same area. So the whole idea behind isolation forest is that the easier a vector is to become isolated from the rest, the more its level of anomaly. So, for example, the orange vector is rather anomalous instance because it was easily isolated from the rest, and the blue vector here is not an anomaly, or its level of anomaly is quite low because it was very difficult to isolate it from the rest. So basically, I have covered the first part. Remember that we want to identify genes that were acquired by horizontal transference. So the whole idea is that we want to identify those genes that were inherited from horizontal mechanisms and distinguish them from the genes that were acquired by vertical transference. So in order to do that, we require an algorithm or a function, which is more or less what I have depicted in the previous slide. But we also need some attributes. We have to characterize genes in a genome in order to apply that characterization and at the end to tell apart the genes that were acquired by one of these two mechanisms. The whole idea is quite simple. We have to analyze a genome, let's call it G, and we will create an equivalent to what in natural language processing is called a token. We call those tokens here k-mers. A k-mer is a length of a sequence of length k, and we will characterize a genome in terms of some properties obtained derived by the k-mers. So each sequence of length k, in this case k equals 3, and if that's the case, we call these k-mers codons. So a genome will be characterized in terms of properties of these k-mers, and in fact we will split the genome into different windows, and at the end we are going to identify those windows that contain genes that were acquired by the horizontal gene transfers. So the whole idea is to characterize each k-mer, here represented as a circle, a different color circle, in terms of two attributes. The first one is to count the number of tokens that separate a token from its previous appearance. For example, token orange here is located 3 positions to its previous appearance. The same for token blue, and for token green, that number is 0 because it is the first time it appears. And the second characterization for each k-mer is the number of tokens that separate that k-mer from the last novel token. A novel token is a token that appears for the first time. So for example, if we are looking at k-mer blue, the distance to the previous novel token is 1 because the previous novel token was this orange. And if we look into this blue token, the distance to the previous novel token is 2 because orange was already appeared at the first place. So when we are looking at this orange token or k-mer, it is not novel, but the novel one is this one. So at the end, we are characterizing each k-mer in terms of these two attributes. The ansatz here, the hypothesis, is that genomic material acquired by horizontal gene transference is an anomaly with respect to genes or sequences acquired by a vertical gene transference within a certain genome G. This is our main working hypothesis or ansatz, and based on this characterization, we are more or less able to identify those precise sequences. So what we did was to, I'm almost finishing, to divide a genome G into different windows, large windows, and in some of those windows, there are some genes that might have been acquired by horizontal gene transference. The idea is that the whole number of windows will be represented as a point in a high-dimensional space. This high-dimensional space is defined by the attributes I just described in the previous window, and we applied to a certain genome, we applied an anomaly detection algorithm in order to detect peculiarities, that is, in order to detect anomalies or horizontal gene transference. We basically analyzed the Mycobacterium tuberculosis genome. Here is some description. I'm not going to talk about much of it, but the whole idea is that we were able, moving forward, this is basically the previous, second to last slide. We analyzed the whole genome of Mycobacterium tuberculosis. You can see the whole genome here. Each point or line is a small window in that genome. And in the y-axis, you can see the anomaly score obtained by isolation forest. And the red points, the red square and red circles, are actually genes that have a high level of anomaly, but the literature tells us that those genes were indeed acquired by horizontal gene transference. So we have applied an unsupervised learning algorithm able to detect relevant genes, actually genes that were acquired by horizontal gene transference, and we did without any external information. We didn't have databases because there are not that many. Actually, there are very, very, very few, and it is quite difficult to correctly classify those. But at the end, we applied we used an unsupervised method in order to detect anomalies, and those anomalies are indeed genes that were acquired via horizontal transference, or it is also called lateral transference. So we are quite happy with this. Our colleagues in biology, in the biology field, we have some collaborations with people at the immunology department at the Instituto Politécnico Nacional, your colleagues. They are quite happy with this because we have been able to detect relevant regions in the genome. So basically, that was all. Sorry again for the rush. I was well. It was quite unfortunate that my laptop didn't work, but this is more or less what I wanted to present. All the software, all the papers, all the data that is we produce in this work, in this project, we call it the Anomalocaris project, is available here. Please visit us, and I'm more than happy to receive questions if there are any from the audience. Thank you, Ram. Thank you. I forgot to thank the organizers at the beginning. I was so in a rush, but I take the opportunity to thank the organizers, especially Ram. Thank you.
Thank you, Antonio. No, on the contrary, thank you very much for participating. Can you hear me properly?
Yes, I can hear you.
Okay. Okay, thank you. So thank you for your presentation. Are there any questions here? Okay, I'm sure we have a lot of interesting questions, but we are a little bit on a rush. So please, our apologies, but well, we have to switch to the next session. Thank you, Antonio, and well, I hope we can meet again soon in person.
Thank you. Nice seeing you all, and especially you, Iram. Thank you.
Thank you very much. Well, with this, we finish our session on cognitive information modeling and processing. And then, well, we have no time for a break. Sorry for the adjustments. We will begin now with process systems of computing. Our session chair is Prometeo Cortez Antonio, so I leave him all the controls of the session.
Thank you very much, Dr. Iram. You can listen. Yes? Yes, okay. We will start with session 6, fuzzy system and computing right now. The rules for this workshop is that the speaker has 10 Okay, you can see principal screen.
Yes.
Um, okay. And sorry, you can see the first slide with style of the paper, or you can see the outline, because I don't know.
We see the outline.
We start in a minute, please. Wait a second.
And then just to remind you, this is session number 1. In case you want to enter other sessions, please put your link that is registered you properly to the CCAIS and the room number you decided.
Okay, just to remind you, if you want to join other session, please verify that the number of room is correct. This is session number 1. So we are waiting for Prometeo, but in the meeting, maybe we can start with clustering Android ransomware families using fuzzy hashtags similarities. Is Horacio Rodriguez and Gregory Isidoro Ponciano Escamilla here in the room?
Yeah, I'm here.
Okay, so let me see. Tom's trying to join again. So maybe if he has a problem with his connection, we can wait a few minutes. You are muted, Prometeo. We can see your screen now. Just please open your microphone, Prometeo.
Okay. Um, problem. Well, I start with the presentation. The presentation is entitled Clip Sets, Taiwan and Type 2 systems. This is set in the context of linguistic variables and rule-based systems compute. Okay, for this, so only present the principle of the paper for reason of time, and this paper is directed for beginners in Type 2 fuzzy sets and systems. We present some novel dissertation about how the cognitive system with linguistic variables. Linguistic variables were defined in the fuzzy logic. However, as we saw in this work, cognitive system that use terms rule-based systems. As the behavior of rule-based, where the fuzzy values of the variables are modeled with type 0, type 1, and type 2 fuzzy. By example, we analyze the similarities of difference of these fuzzy systems. In paper, we difference the representation of sets by set of elements which satisfies some
Well, sorry, we have some technical problems with the connection with the Professor Prometeo. So I think we will move his talk to the end of the session. So please, I would ask our colleagues Horacio Rodriguez Bazán or Ponciano Escamilla, please to start the presentation. Please, Horacio, if you are here, then you can begin your presentation.
Hi everyone. Dr. Prometeo has a problem with his connection. So we need to present the next presentation, named Clustering Android Ransomware Families Using Fuzzy Hashing Similarities, presented by Horacio Rodriguez Bazán, Grigory Sidorov, Ponciano J. Escamilla Ambrosio. If someone in the room, please. Okay.
If not, we can move the presentation to the next one. So we will call Claudia Gonzalez or Cesar Torres. Are you here?
Yes. Hi, can you hear me?
Yes, yes.
Yes.
Can you begin the presentation, please?
Yeah, sure, no problem. Give me a
Okay, so
second.
let me introduce you in the meantime. Now we will have the work from Claudia Gonzalez and Cesar Torres of fuzzy convolutional neural network model applied to classification problems. Please go ahead.
Yeah, can you see my screen?
Yes, and we can hear you properly.
Okay. Hello, my name is Cesar Torres. I'm from Tijuana Institute of Technology, and I'm going to present you the article Convolutional Neural Network Model Applied to Classification Problems. Okay. Oops. Okay. The agenda for this presentation is the following. We have introduction, objectives, background, proposed methodology, experimentation, discussion, conclusion, and references. Convolutional neural networks stand out as a prominent deep learning architectures. Their strength lie in the efficiency of handling substantial numbers of input samples, leading to an effective outcome. However, it's crucial to acknowledge that uncertainties may arise in the input data due to the presence of inaccuracy or unreliable information. Fuzzy system approaches reasoning with uncertainty similar to humans think and make decisions. In order to enhance to perform the intelligent models, we have chosen to employ hybridization techniques that combine the neural networks with fuzzy logic. Our objective is to develop a new deep learning model that combines the principles of CNNs and fuzzy logic to perform a classification problem oriented to the classification of traffic signs. Okay, for a background, we have the convolutional neural networks. The CNN consists as a supervised technique inspired in the visual cortex and the brain to identify patterns with visual stimuli. The basic architecture of a neural network consists in the input layer, the convolution, an aggregation layer like the pooling, dense layer, and the output. For fuzzy logic, we implement a nonlinear representation similar to human reasoning. The utilization of linguistic terms sets it apart to traditional logic that offers binary values to its representation in a continuous space, taking into consideration uncertainty. The concept was introduced in the 70s by Lotfi-Zadeh due to the limitation of the classical logic. Okay, for our antecedents, in the literature, we can find a variety of works that have addressed the combination of neural networks and fuzzy logic. Xu created a convolutional neural network that includes fuzzy inference system in the fully connected layer that is presented to perform a classification task. Nguyen presented a fuzzy convolutional layer with fuzzy data and fuzzy kernels in a multimodal model to perform sentiment analysis. And finally, Lin presented a convolution of fuzzy neural network based on feature fusion and to do a model classification. For proposed methodology, the implementation is inspired in the traditional convolutional neural network, where the data is multiplied by the random filters to perform the feature extraction. In this case, we propose the falsification of the data and the random filters to perform the feature extraction with fuzzy numbers. Okay, in this case, we utilize three membership functions: the Gaussian, triangular, and the S membership. The falsification for the data and kernels we have proposed to experiment with two. Okay, the range for the functions is determined by the range of the images, which is 0 to 255, and for the kernels is -1 to 1. In this case, we proposed 4 models to perform the classification test. They are compared against each other. In this case, the 4 models are simple architectures with no more than 4 convolution layers and 1 or 2 dense layers. We perform 3 independent experiments for each preprocessing model. For each preprocessing, the model were trained with the following parameters. We utilized 100 bit box, space categorical cross-entropy, the Adam optimizer, and a batch size of 128. Okay, for our experimentation, we experimented with 2 databases, the Belgium TS and the CTSD database, both databases with more than 50 classes each other and less than 5,000 training elements. Here is the example of the Belgium TS database, and here is another example of the CTSD database. In this case, I'm only going to show you the results obtained from the best rating for each of the models. This is for the Belgium TS database, where we got a 97.5% of accuracy. And for the CTSD database, we got a 75.3% of accuracy with our best model. Okay. To validate the results, we apply a seed test to conclude the existence of significant evidence between the pre-processing done. For null hypothesis states that the utilization of the triangular membership functions offered less or equal precision when compared to the Gaussian membership function. And our alternative hypothesis states that the utilization of triangular membership functions offer better precision when compared to the Gaussian. Okay, here is the results of the statistical test. As we can see, we passed the test when applied to the Belgium TS database, and with the 4 cases, and with 3 cases on the CTSD. We also applied a second statistical test to compare the triangular membership function against the raw images. With this, we mean the RGB data. And in this case, we only have the results with the first model. Okay, for the discussion, with the results of the Belgium TS show a particular loss in precision with the S and the Gaussian membership function when utilized with the model. The utilization of a triangular membership function when applied to the filters and the combination of the filters and the data did not result in a significant improvement. The application of the triangular function only to the data presents an improvement with the proposed models. The results of the statistical test for the comparison of the Gaussian MF against the triangular MF did not result in a significant evidence or of an improvement in accuracy. When we apply with application to the CTSD database, it tends to follow a similar pattern, but in the case of the triangular function, we see a significant improvement of up to 3% of accuracy to the model. And in this case, we see a significant increment when applied the application of the statistical test to compare the fuzzy expression against the RGB images showed the existence of significant evidence when we utilize the first model, the fuzzy treatment, the generated alternative. Okay, for our conclusion, we have that we can determine the utilization of a fuzzy membership function offers an improvement in the precision of the models, especially with the triangular one, which affects particularly the models trained with the CTSD database, which improves significantly its results. The usage of fuzzy kernels or the combination of kernel and data have a negative impact by performing the experimentation with the new models. And for future work, we plan to extend the fuzzification of filters and data to the dense layer. As well to include more types of membership function, as well to extend the experimentation to the type 2 fuzzy logic. Okay, here are some of the reference. Any question?
Hi, thank you for your presentation. So if someone say any question, please open your microphone or... Okay,
Say, are there
I have...
ways to...
Okay, are there other ways to approximate function? For example, to try different forms for a part have to be in order to be efficient?
Complexity of the curves. Well, in this case, you can try any membership function. Just settle to 3 right now because the amount of experimentation, because we are doing 3 separate experiments for each one. So the data, the kernels, and the kernels and data, just to see how it behaves the model. In this case, you can take any. You can go for either Gaussian Bell or either, yeah, I mean any function. You only need to limit the ranges from 0 to 1 for the data, and or well, except from 0 to 255 for the images, and -1 to 1 in this case because we use the Xavier initializer. Yeah, we will need to experiment with more complex curves to see how it behaves with the model.
Okay, thank you so much for your presentation. And Tridam, can you play something?
There's any other question?
Okay, thank you so much for your presentation. And I would like to ask about the first presentation.
Yes, can we try again, Professor Prometeo?
Yes.
Presentation? Yes, he's changed to my computer. I'm Oscar Castillo, also co-author. So we will try again.
Okay, thank you so much. You have only 10 minutes to present and 5 minutes to question and answer. Okay, thank you. Okay, we have a message for Dr. Iran. We will move to the end of the presentation because the time is reduced. So we need to continue to our program.
Okay.
So I'm sorry. The next presentation is Fused convolution neural networks model Fused convolution neural network model applied to classification problem. This is the okay. Next is Spatial automatic Hessian fuzzy clustering applying to image segmentation. Dante Mojica Vargas, Birna Virina, Bella Rincón, Antonio Luna Alvarez. It's someone in the room?
Yes, Birna Bella.
Okay, thank you, Birna. Please, can you share your screen? And you have 10 minutes to present and 5 to question and answer.
Okay. Oh. Okay. Ok, tengo problemas con mi presentación. Okay, give me a second, please. Okay. Can you see my screen?
Yes.
Okay. Okay, good afternoon, everyone. Thanks for coming. I'm Birna Bella, and I tell you about the paper titled Fast and Automatic Hessian Fuzzy Clustering Applied to Image Segmentation. I'm going to divide this talk into 4 parts. First, a brief introduction about the research, and then I go on to explain the proposed method, followed by the experimentation and the obtained results, and at the end of this talk, the conclusions and the reference. Let's start by the introduction. This research focused on image segmentation, that is dividing an image into more homogeneous regions with similar characteristics that belongs to the same objects. Fuzzy means algorithm is one of the most used algorithms for these tasks. Since it allows some flexibility to assign a pixel to groups simultaneously, assigning them a degree of membership. However, it is necessary to define a precise value. So this theory has been extended to others in different forms that intuitionistic fuzzy sets that assigns a degree of membership and assigns a non-membership degree and an indecision degree. But the difficulty in establishing the degree of membership is due to the fact that there is a set of possibilities or some possible values and not a distribution of possibilities or a precise value. So that is why hesitant fuzzy sets were created that allow having several positive membership values for a single element, allowing us to better describe situations in which there is uncertain when making a decision. Therefore, this research proposed an algorithm that applies this theory of hesitant fuzzy sets to image segmentations. The algorithm, in addition to obtain better results than some of state-of-the-art methods, both in execution and quality, and is also capable of automatically finding the number of regions in which the image will be segmented, and also propose a way to generate hesitant fuzzy information through fuzzy relations. Here we have the definition of the hesitant fuzzy set. The hesitant fuzzy set are a set of values on interval of 0 to 1 that represent the possible degrees of membership of an element in the set. These sets are applied to image segmentation, and we need first define an objective function based on the least square distance between the centers and the data, where this represents the hesitant fuzzy elements corresponds to the each data. We have the fuzzy matrix and the center of the groups, and C is the number of the group in which we'll segment the image, and M is the fuzzy parameters. The center of the group are in terms of hesitant fuzzy sets too. And we have the distance. The distance is the hesitant normalized Euclidean distance that measure the distance between the data and the center of the group. Since the objective function has several variables, the fuzzy matrix and the center of the group, we need to apply a method to minimize this objective function, and we can use an optimization process with the Lagrange multiplet techniques, for example, and we need to stabilize the partial derivatives in order to find the equation for the membership matrix and the centers. Another important concept in this research is the Kalinski-Harabar index, which measures how similar an object is to its own group compared to other groups. This index helps us to find the optimal number of clusters in the proposed method. Now move on the proposed method. Let's have a look at this diagram outlining the proposed method applied to image segmentation. The method is divided in 3 stages. First, we filter the image and reduces to find the number of clusters using the Kalinski-Harabar index. And here the hesitant fuzzy matrix of the image is also obtained. This matrix is using to calculate the centroids of the groups that we got on stage 3 as initial centroids that we segment the image. According to the literature, there is no a database that gives us hesitant information. This is given by people, by experts by experts. So we obtain it by using membership function based on fuzzy relations such homogeneity, color space, and also use a statistical approach to describe the textures of the image. This with the objective of having an algorithm that is easy to implement. We use this statistical approach and no other approach. For more details, this algorithm 1, summarizes the implementation of this method. It has as input a color image with each filter with a median filter. Since it is less sensitive to extreme values, then a reduction of the image is done to find the number of groups into which the image will be segmented, as well as to find the initial centroids. In steps 3 and 4, the transformation of the image to the hesitant fuzzy domain is carried out, and the initialization of the hesitant fuzzy matrix using the relationship mentioned above. Finally, an iterative process is performed to update the centroids of the groups and the fuzzy matrix and obtain the segmented image. Here is the algorithm used to describe the reduction process. And as I mentioned above, the number of clusters, this is the algorithm to find the number of clusters. It's determined by the Kalinski-Harabas index, and this index is calculated with the clustering result of the fuzzy means algorithms for 2 to n clusters, number of clusters, and we select the highest value to be the optimal number of clusters. Moving on now to the experiments and results. The performance of the proposed method is demonstrated through 3 experiments. First, the execution time and the number of iterations, the convergence, and then the quantify the segmentation quality and quality of clustering in user repository. The evaluation of this algorithm was performed with image from the Berkeley segmentation dataset because they have different textures and illumination change. And to evaluate the segmentation performance, we select some metrics that measure the similarity and difference between segmented image and the ground truth, the amount of information lost or gained in the clusters, as well as the average displacement error at the edge. Well, to evaluate the clustering in the UC repository databases, other metrics were selected that measure the quality and the similarity between the groups. For the first experiment, the proposed method converges in a smaller number of iterations and in a shorter time than most of the other algorithms, which is compared. We can observe that fuzzy Siemens algorithm is faster, but converges in more numbers of iterations. This table represents the evaluation of image segmentation of some image. These are complicated. The evaluation. We can observe that the algorithm, the proposed method, have the better result in almost most of the metrics. And the following image. illustrate the result obtained of the segmentation, we show some sample image. Here we can show that they have different textures and illumination shades, and the proposed algorithm has better results than the others, being visually more similar to the ground truth. This figure shows that the proposed method generates more homogeneous regions and delimits the edge of the better than the others algorithms. And this one, we observe that the proposed algorithm have a result, and these two algorithms are use the same technique using the Hessian-Fossey set theory, but this algorithm use initialize the Fossey matrix with using Fossey Siemens, and the proposed algorithm used the Fossey relationship, and we can observe that the algorithm proposed achieve a better performance due to the initialization of Fossey matrix. On the other hand, the quality of the clustering was evaluated with the UC repository database, obtained an advantage in the metrics selected. And we can also observe in this graph the trend that methods follow, and the proposed method always has the highest value. And finally, this graph show you the result obtained by the Kalinski-Harabas index using to find the number of clusters. And we can, with this graph, we demonstrate that this index is able to correctly find the number of groups in each one. With the red circle, we show the optimal number of clusters. In conclusion, let me sum up my main points. In this research, a method for color image segmentation is proposed based on the theory of Hessian-Fossey set and using Fossey relationship to initialize the Hessian-Fossey matrix. The algorithm found the number of regions into which the image is segmented and is also capable of accelerating the processing time due to the image reduction and using the centroids obtained to segment the original image, making it converge in no more than 5 iterations. The experiment showed too that the algorithm is capable of obtaining better performance compared to some of the state-of-art algorithms, both for image segmentation and those from the UC repository. And for future work, is intended to add another type of textures to initialize the Hessian-Fossey matrix so that the method will be capable of segmenting the graded image with noise. That brings me to at the end of my presentations. And this is the reference, and thanks for your attention.
Thank you so much for your presentation. If someone has a question, please open your microphone or write in the chat, please. Okay. We have a question. Can you select another clustering algorithms instead of FCM when you compute the number of clusters using CH index?
Yes.
In the chat.
Yes. Yes, we can using another algorithm of clustering to find the number of cluster. The number of cluster, but we select the Fossey clusterings to have a easy implementation of our algorithms. But is select another.
Thank you so much. I have another question about you. For example, in your slide 21, why do you think that the last task does not give as a good result as the others?
This one?
21.
Okay.
Yes.
What was the question?
Why do you think that the last task does not give us a good result as the others? It's 21 or it's 20? I don't remember the slide. You present a table.
Maybe this one?
No, it's 21.
Sorry, I don't understand you. Sorry.
Why do you think, why in the last task when you write the image, the results are different than the others?
The last image, this one.
The last, and this one.
This is for the proposed agri. Maybe we have different illuminations, but here we don't have a better good result. But in the forest or these trees, we have a better delimitation of the borders. And this is because the initializations use the textures. We use the textures to initialize the matrix that use it for being the segmentation.
Okay, thank you so much for your presentation. I don't have other questions, so that's all. Thank you so much. I give the applause for you.
Thank you.
So the next is on the explanation of COVID-19 blood test variables using FUSI models. Please, Arturo Telles Velázquez, Piedra de Liz, Rafael Salgado Leiva, Raúl Cruz Barbosa. Someone in the room?
Yes. Can you hear me?
Okay. Yes. Can you hear me? We continue with our program. At the end of, we return on the presentation for grip sets by Prometeo Cortés and clustering under ransomware by Horacio Bazán. Okay. So now, can you start, please?
Yes.
Arturo. Thank you.
Am I sharing?
Yes. Thank you.
Can you see when I change it?
Yes. Can you start, please?
Okay. My name is Arturo Telles, and my paper name is on the explanation of COVID-19 blood test variables using fuzzy models. Okay. Since the end of the 2019, the COVID-19 pandemic has paralyzed not only social relations, but also the worldwide economy. During the advancement of this disease, a wide range of prevention and mitigation measures have been proposed. Among them, we highlight physical distancing of at least 2 meters between individuals, hand hygiene, wearing face masks, and test for detection. With the artificial intelligence technique improvements and the advancement in technological tools, patients can be diagnosed as positive with high reliability by using routine blood tests such as hematological profile and blood chemistry tests. Several works have been carried out with the traditional machine learning techniques as they have been shown to offer good performance. For example, Kowanu et al. Obtains one of the best results, achieving an accuracy of 99.29%, a sensitivity of 92.79%, and a specificity of 100%, using only the supervector machine and other implementations in its pipeline. This paper performs an analysis comparing two evolutionary explainable fuzzy models that make inferences in the pipeline with a blood test dataset for COVID-19 classification. These are called evolutionary clustering structured fuzzy classifier or ECSFC, evolutionary fuzzy decision tree, or EFDT. Also, it contributes to the interpretability of artificial intelligence models for COVID-19 detection and to more suitable patient triage hospital admission. The dataset used is Hospitale Israelita Albert Einstein in Brazil. This dataset has 5,644 samples with 111 features. The class distribution is as follows: 5,086 negative cases against 558 positive cases. So we can see that this dataset is very, very imbalanced. Our methodology incorporates several stages. For example, the first one is cleaning, removing the columns with at least 90% of missing values. An imputation, the multivariate imputation by chained equations. We selected this due to its robustness. We also use the ranking feature selection using the ANOVA score, the Q-score, or the mutual information score. Also, we provide a scaling using the max apps or the standardized or none. Okay, this process of optimization requires a structure and parameter identification for the ECSFC. For this stage, we find a low accurate classifier that is obtained using several clustering algorithms like k-means, like agglomerative, like the fuzzy C-means, and Gaussian mixture model. These algorithms are used to find the parameters A and C in this equation. This equation represents the equation for the generalized Bell membership function. In the case of the ECSFC, a high accurate classifier using differential evolution is obtained by optimizing fuzzy set slopes and root consequence. Also, we obtain a very stacked feature plot to see at a glance what is the pattern for the COVID-19 disease. In the case of EFDT, the parameters to optimize are the maximum depth, fuzziness, the criterion, the minimum membership to split, and the minimum membership to leave. The objective function for minimization comprises the only accuracy strategy, the only sensitivity strategy, and the fair sensitivity and specificity strategy. Notice that it has in the formula we assume the accuracy and the sensitivity that depending on each strategy. I'm sorry. For the EFDT model, the strategies are very, very similar. The only difference is that we have the last term, the M sub I means that the maximum depth of the tree, and M uppercase means the maximum possible depth for the trees to be built. As a first phase, we make a grid search using the k-means algorithm in order to find the best pipeline, the best selection in using our fitness strategy. only accuracy, only sensitivity, and fair sensitivity and specificity. And the best value, the best results can be found in the last row of this table, where we found that the number of clusters is 3. It is much better with 3 clusters, and the mutual information in the score in 2 variables, achieving an accuracy of 96.37% and a sensitivity of 96.83% and a specificity of 96.43%. Okay, the accuracy. Now in this second phase, we made a grid search where we tested the 3 clustering techniques and several number of clusters from 2 to 9. And we found that there are 2 models that we must highlight. The model B and the model C, that we find the best results. Now we're going to see why is the best results, are the best results. Okay, and the sensitivity in the model C achieves the best sensitivity for this problem, achieving a sensitivity of 96.67%, and in this last table, a specificity of a 98.71%, which surpasses the number, the performance of the model B, which is marked as B in this table. We can see also that the fastest means is the best algorithm for doing this task, for achieving the structure identification for the fuzzy system. The weighted stacked feature model, the weighted stacked feature plot for the model A includes this is the plot, the stacked feature. We can see that there are three features or 3 linguistic variables, and we can see at a glance that there is a pattern.
1 minute.
Excuse me? Okay.
1 minute, please.
Okay. The weighted stacked feature plot, we can see in a single plot, the red points. Where is the pattern in the positive cases? The weighted stacked feature for model B also we can see a pattern in red points for the positive cases, and we can build a rule using this pattern. For the model C, also we have the red points. For the EFDT results, we can see that the fair sensitivity and specificity strategy achieves the best performance, achieving an accuracy of 98.23% and sensitivity of 96.006% and a specificity of 98.43%, achieving a maximum depth of 3. And we achieve a tree like this with a level of 3 with maximum depth of 3. Like conclusions, we find that the fuzzy C-means is a suitable clustering algorithm for ECS FC to solve this classification problem. We find that the EFDT model produces similar results when it's optimized with the algorithm. In both the ECS FC and the FDT models, it's possible to obtain simpler models while preserving sensitivity. It was possible to verify the usefulness of our the stack feature plot proposals, which allowed us to visualize in a simplified way in which features and which linguistic terms are related to the COVID-19 disease. And a limitation of this model is a selection of an adequate number of clusters to carry out the COVID-19 classification. So we suggest that the search for the number of the clusters should not exceed 10. And thank you very much for your attention.
Thank you so much for your presentation. Truly very interesting. Now we move to the question and answer sessions. Only have a time to one question, please. One. Any question? Okay, we have a question in a chat. When you implemented grid search, did you use the validation split?
Yes, we made a validation split.
Okay.
Yes, we first made a simple holdout validation.
Thank you so much for your answer. Thank you. Thank you, Fernando. So we send a big virtual round for applause. And thank you for your presentation. We will continue to the next presentation. That is performance on different evolution algorithms for constrained numerical optimization problems by Amielec Pérez Flores, José Hernández Torruco, Cristina López Ramírez, Betania Hernández Ocaña. If someone is in the room, please.
Yes, can you hear me?
Yes, I can hear you. Good. You can share your screen. You have 10 minutes to report your presentation and 5 minutes to question and answer, please.
Yes. Can you see my screen?
Yes, thank you so much. You can start.
Okay. Good afternoon, everyone. My name is Amielec Pérez Flores, and I discussing the performance of differential evolution algorithm for constrained numerical optimization problems. This work was conducted in collaboration with José Torruco Hernández, Cristina López Ramírez, and Betania Hernández Ocaña. Within metaheuristic, in the area of evolutionary algorithms, there is differential evolution, which has been shown to be efficient and effective for solving constrained numerical optimization problems. In general, the phases of differential evolution are initial population, crossover, mutation, and selection. It is asked whether the stopping criterion has already been met. If the criterion is met, the process is complete and the best solution are reported, which are chosen by the LEDs. If the stopping criterion is not met, it returns to the crossing process and continues until it is finished. For the study, the differential evolution version of DRAN1 was used. Constrained numerical optimization problems are real-world problems that have been mathematically modeled. These problems have several solutions, have an objective function that can be linear or non-linear, dynamic, single, or multi-objective, and can be separable or non-separable. Range for each variable and the constraint that can be equality or inequality. All these characteristics make it complex to solve constrained numerical optimization problems. Differential evolution algorithm was coded in Java language programming. Graphical user interface was developed with a characteristic of parameter adjustment, basic state and performance metrics, results table, and a convergence graph. This allows the algorithm to be used to solve different problems without interacting directly with the code. And the characteristic of the test problem that were used to evaluate the performance of the algorithm are present, showing in each one the best solution found in the state of the art. The evaluation of the algorithm was carried out in 2 experiments. The first, then, the best value of the algorithm parameters were found. For this purpose, the 3 combination of value of the most used parameter were chosen according to the current state of the art. With these values, 3 independent execution were performed on each problem, and the best combination was chosen based on the statistics. The combination that worked based on the problems to find the best solution was the first combination. The following table shows the winning combination for adjusting the algorithm parameters and thus being able to evaluate the problems again. In the second experiment, 30 independent executions were performed for each problem, with the number of individuals being 100. The value of the mutation operator at 0.5, the value of the crossover operator at 0.9, and 30,000 evaluation as the stopping criteria. The following table shows the best solution, the mean, the standard deviation, and the worst solution found in each problem. By comparing the best solution found for each problem found in experiment 2 with the best solution found in the state of the art, it can be observed that the differential evolution algorithm has good performance by providing similar solutions. In the convergence graph of each the evaluated problems, it can be seen that the differential evolution algorithm implemented in the interface reach the best solution found in the state of the art for each evaluated problem, and needing a maximum of 70 generation. In conclusion, differential evolution effectively solves the 5 proposed problems with very few parameters to calibrate, with crossing and mutation as its main operators. The interface developed for differential evolution showed that the process of configuring independent neurons and adjusting algorithm parameters can be even simpler for user in areas other than computing. Future work is required to compare the differential evolution algorithm with other meta heuristics, solve multi-objective problems, and implement crossover and mutation operators in a random and adaptive manner. With Consejo Nacional de Humanidades, Ciencias y Tecnología for supporting the master program in computer design of Universidad Juárez Autónoma de Tabasco of División Académica de Ciencias y Tecnologías de la Información. The reference and these are the contacts. Thank you for your time.
Thank you for your presentation. Okay, we have a question for you. Can you resolve the difference by using different F and CR values? CR values?
Can you repeat, please?
Yes. Can your results be different by using different F and CR values?
Yes. the values F and CRs can difference.
Okay. It's in the chat, the question. It's program Arturo Tiguetes.
Yes, yes.
It's okay. Thank you, Arturo. Thank you for your question. And in other further channel, what would you recommend there in general for evolutionary algorithms to perform better?
Can you repeat?
Yes. What would you recommend in general for evolutionary algorithms to perform better?
They recommend for
Your recommendation in general for this type of algorithms.
For problems, I don't know. I don't know.
Yes. I don't know, what do you know some recommendation to improve the function?
Oh, the function.
The function.
Function.
Change the question in Spanish,
Yes,
like you respond
yes.
in English. ¿Qué recomendarías en general para que los algoritmos evolutivos funcionen mejor?
Okay. Que se pueda, por ejemplo.
Please.
Sí, sí, yes.
Asking
Sí.
in English, your answer, please. Sorry. Okay, no problem, no problem. It's okay. No problem, no problem. Thank you so much for your. Oh no, no problem. Thank you so much for your presentation and send notes for you. Okay, thank you so much.
Thank you.
So for the program is the last, but now we will return to the first two presentations that explain some technical issues at the beginning. So we start again with three steps, type 1 and type 2 fuzzy sets in the context of linguistic variables and rule-based system for cognitive computing by Prometeo Cortés, Ferrer Valdez, Patricia Melin, and Oscar Castillo. I can see your screen, so you can start the presentation. Only have 10 minutes to the presentation and 2 minutes to question and answers.
Okay, thank you. I present told about crypt sets, type 1 and type 2 fuzzy sets in the context of linguistic variables and rule-based systems for cognitive computing. I am Prometeo Cortés and I connected in the Oscar Castillo computer because I have problem with my connection. Okay. In this talk, I only present the main ideas of our review in paper. This is for reason of times, but the paper is directed for beginning in type 2 fuzzy sets and systems. And however, we present in paper a novel dissertation that relate the linguistic variables with cognitive systems. Linguistic variables were defined in the context of fuzzy logic. However, we will show in this work cognitive systems that use linguistic terms can even make use of classical sets. We're going to develop a dissertation that justified why type 2 fuzzy sets are more suitable for modeling linguistic values in a cognitive systems or rule-based systems. The paper analyzed the behavior of a rule-based system where the fuzzy values of the variables are modeled with type 0, type 1, and type 2 sets. And by examples, we analyzed the similarities and differences of these fuzzy systems. In paper, we present the definition for crypt sets, type 1 fuzzy sets, and type 2 fuzzy sets, and This is more clear when we use a graphical representation. In paper, we present what is a linguistic variable and linguistic values. Linguistic variable can be used in both quantitative and qualitative variables. A linguistic variable can be characterized by 5 elements. And in this work, we focus in quantitative problems. That is, the variable initially is in real space, and this is translated to linguistic approach. In paper, we discuss some possible labels to assign linguistic values. For example, we present how to define labels for a feature or characteristics that is considered as a variable. To consider a feature as a variable, this should be have at least 2 values, and you can assign these 2 values with antonymous words. For example, for position, and this word should be related with the variable. For example, for positions, if you have 2 values, then we can use near and far linguistic variables. But if we have more values, we need add another word or linguistic value. For
Prophet, I'm
example,
sorry. We don't see your presentation progressing.
What
Only,
slide do you see?
only see the slide 1.
Slide 1. Okay.
Yes.
And
Okay.
with this,
Yes.
I
Slide
present
9. It's
in
okay.
this in the
Okay.
I present this in this format because I don't know why I can see the slides.
No problem. No problem. At the moment, you are in slide 9. It's okay.
Okay. This
Continue,
is
please.
the slide 9. You see the slide 9? 9?
Yes, 9.
Yes. Okay. If there are a problem, you can say me. For example, if we have a variable position and we define 2 values for this variable, we can use antonymous words that describe this variable. For example, two values can be near and far, and if we have another value, we can employ a gradual values, linguistic values for these variables, and so on for more values for values for this variable. In paper, we present some examples that is shown in this table. Then we can see the linguistic values are very imprecise. We can define near or far in a deterministic way, because these are very imprecise vagueness or subjective definitions. Then this is the principal dissertation in this paper. We can see that for type 0, we have problems in the definition of cold and hot values, because elements that are near to the boundary are defined as different set or different concept, but these are very close, very similar. And the problem with type concepts, such as cold and hot, are defined in a deterministic way. And if you can see that for type 2 fuzzy set, when we define this concept, we can generate a uncertainty region. And for this reason, this model of type 2 fuzzy set are more adequate for implement computed good words or to use linguistic. In paper, we expose some criteria for define the number of linguistic values that depend on the application. From the perspective of psychology and cognitive science, a variable should have 7 linguistic values for effective human processing information. In practice, most applications such as control, robotics, or other areas regularly input variable or fuzzy cognitive system have 3 to 5 fuzzy sets. In principle, the number of linguistic values can be defined through a syntactic rule with context-free grammar. However, commonly the number of linguistic values is determined by trial and error. To define the semantics of linguistic values, normally we use parametric membership function that characterizes fuzzy sets in continuous variables. This allows the linguistic qualifiers to have membership with a gradual transitions. Determining the parameters of the membership function depend on the problems, and these are very subjective and depend on the applications. Over this direction, many research support that words mean different things to different people. And in this paper, we present a dissertation and extend this phrase to the words means different things to different people at different contexts. In paper, we present how to design linguistic values in the context of cognitive system, and we present an example in how we can define two values using type 0, type 1, and type 2 fuzzy sets. And we present how to increment a value for a variable, okay, that is passed for 2 values to 3 values and so on. We also plans in the paper the optimization of linguistic values and some consideration and criteria to optimize the fuzzy values. And we put attention in the semantic, in the extremes and intermediate linguistic values. In paper, we present the mathematics related with type 1 and type 2 fuzzy systems for inference procedures. And finally, in paper, present the behavior of a rule-based system that use linguistic values implemented with type 0, type 1, and type 2 fuzzy sets to control velocity of a DC motor. This example is inspired in a problem presented in a paper in which a cognitive system is made out of linguistic values, and with a learning procedure, an optimal rule-based system and linguistic values were found determined for a type 1 fuzzy system. In this example, the authors define a system with 2 inputs and 1 output, and all the variables has 3 values, 2 linguistic values, and they determined the optimal rule-based systems with 9 rules. And we, in this example, we translate this example to a case where we change the fuzzy sets with type 1, type 0 and type 2 fuzzy sets, and we compare the behavior of the systems. And for a global point or global view, the behavior of these 3 different systems, we can see that are very similar, and the behavior, because if you put attention in right upper region, we have the most the maximal values of the output, and in the front left region, we have minimal values in the output. But in type 0 fuzzy set, when we use type 0 fuzzy set, the behavior of the surface is very limited and only have 3 different values for this case. And with type 1 fuzzy set, yes, with type 1 fuzzy set, we can see that we have a infinite number of values, and for type 2 fuzzy sets, we can see that it's very similar, the behavior that type 1 fuzzy set, but if we put attention, we have a more robust surface, and this is related with sensitivity of the systems, and this is related with robust systems. In this behavior is related with robust systems or implementation of robust systems in control and robotic areas or problems where data are noisily. In conclusions, in this work, I insist on the definition of linguistic values using type 2 fuzzy set was presented. Type 0 type 1 fuzzy set were used to exemplify the advantage of the computing with words fuzzy sets. General consideration were discussed for the definition of linguistic terms and for the canality of the sets of linguistic terms for continuous variables. Advantage of type 2 fuzzy sets in modeling and cognitive system were highlighted. And this is all for me. Thank you for your attention.
Thank you so much for your presentation. It's really very interesting. And now we move to the question and answer session. For the time, it's only we have a time to one question. If someone has a question, please open your microphone or write in the chat, please. Okay, Prometeo, we don't have a question, and for the time, thank you. We answered your presentation. Thank you. I send a Victor roll of applause for you. Thank you so much. Can you start share your screen, please? Thank you so much. And our last presentation for this session is clustering under ransomware families using fuzzy hashing similarities by Horacio Rodriguez Bazán, Grigori Sidorov, Ponciano, J. Escamilla Ambrosio. Please, you have 10 minutes to presentation and 5 minutes to question and answers.
Hi everyone, thank you so much. Thanks for the presentation. So we're going to start with discussing our part of the research that we performed during PhD. So actually the first part is that we call clustering under ransomware families using fuzzy hashing similarities. So basically what we are doing here is we want to classify multiple ransomware families. There is an issue in here that we're going to explain in this workflow, which is that the corpus are not properly labeled. So this is an attack that we have, or one of the issues that we faced during the investigation, that the corpus is not properly labeled. So for that reason, we perform that, let's say, that part of the research. This is the workflow that we propose. So this research is basically mainly into perform the classification based on the similarity. So first we're starting decompiling the APK, which is an Android application. So we are getting only a Smalley code and also the Android manifest properties. And after that, we are performing a processing. So in this case, we are splitting the processing in 2 ways. So for text cleaning, which is applied to Smalley code, so we are applying for natural language processing techniques, which is punctuation, tokenization, lemmatization, and stemming. And for the Android manifest, so we are performing, we're applying three techniques, which is punctuation, tokenization, keyword extraction. And finally, so we are, let's say, computing the fuzzy hash. In this case, so we are using SD hash. And after that, every APK is going to create a one SDBF, which is a file which contains all the fuzzy hashing that were computed previously and after pre-processing. The second part, well, the next part is the SD hash comparison, in where we are comparing those fuzzy hashing with the rest of the sample into the corpus, because we need to compare, we need to identify what is the measure or the level of similarity between those samples, and based on that, we can assign the ransomware class. And after that, we are evaluating the model based on a confusion matrix. At the beginning, I was talking about that there is an issue, which is the label. So in this case, as a number A and number B, so we are consulting into the virus total, all the MD5 hashes, in order to retrieve which are the labels assigned by the antiviruses. And also we are homologating those labels, because actually there is not a single label for all the ransomware families. So every antivirus label its families as they want. So this is not a standard. So for that reason, we perform a standardization in that part, just in order to evaluate the model and see if our proposal is able to classify the ransomware families into the correct one based on the similarities. So the architecture that we are proposing is, so we have a pool of samples that we don't know exactly which are the ransomware family. As I mentioned, so we are starting with compiling the APK. So we are getting multiple data in here. So the first data that we are looking into is a Smiley code, which is the backcode, is the code that is being executed into the Android in our devices. And also the properties, which is the Android manifest. In this case, this file is in a binary format. So after the compilation, so we are retrieving a XML file. So in the pre-processing, so we are, let's say, applying natural language processing, because we need to reduce the dimensionality for the data that we are waiting, and also performing the standardization just in order to standardize as much as we want, because during the comparison, so we want to measure the level of similarity between them based on the score that we are measured SD hash. So the part of the SD hash, as I mentioned, so we are using this technique, which is part of the algorithm that we are using to measure the similarity between two files. So actually how it is computed is basically the file is split into multiple chunks, and for this chunk is compute one part of the hash, and the final hash is exactly the is put together all the hashes that were previously computed based on that. As I mentioned, so this is going to create an SD hash database, which actually contains all the data in terms of the fuzzy hashing. And after that, so we are comparing all the databases, and based on the score that we are measuring, so we are assigning the family. Regarding to the fuzzy hashing, actually, this is one of the key part that we have in our investigation, which is unlike the traditional hashing. So in this case, the fuzzy hashing allows to measure the similarity between two files, and also this is a score between 0 to 100. This is measure the level of similarity. In our research, we are focused into the strong range. I don't want to explain all of them, because actually there is we have just a few minutes, but actually the range from 21 to 100 give us a result which actually measure the similarity between two files, which producing high score of similarities, which means that those files share content in terms of content. So we can say that those files has the same content in based on the similarity that they share. So for example, if we are measuring two documents, so those documents, for example, we can say that the file A and the file B has, let's say, one paragraph in common. This is the level of similarity that it allows to measure. So the experiment that we performed in this corpus, we're using a ransomware database, which is over 2,000 samples. So, and also we are using SDHash, as I mentioned. So there is a strong score from 21 for 100. And also we propose to split this range sliding intents for the experiment that we perform is from 21 to 100 and for 31 to 100 and so on until 91 to 100. So the experimental condition that we perform, as I mentioned, so the first part is to standardize the corpus. So in this case, so we found 12 classes, which groups all the samples, right? So as we can see, there is no balanced classes. So this is the percentage that we have for each class. So according to the clustering results, so as mentioned, sliding the strongest score. So we found that a couple of range achieves the highest accuracy. From 51 to 100, so we are achieving over to 98%. And from 91 to 100, so we are achieving over to 96%. But what does it mean is actually that for 51 to 100, so the classes that we found, in this case, we can say, or we can group all the classes based on that score. And if we compare with the antiviruses, so we are getting the same results. But if we want to know which members share stronger similarities, so we can move the SDHash range up to 91 to 100. In this case, we are noticed that the members share stronger similarities, and we can say that those members are practically the same. They are practically the same applications. So according to the results, so we are evaluating our method using a confusion matrix. In this case, in the left, so we have the 51 to 100 range. In the right, so we have from 51 to 100. And we can see the confusion matrix. So we are showing the results, which is achieving a good result, despite that we have some misclassification samples that were, let's say, incorrect classified. It doesn't mean that this was completely misclassified, because what does it mean is that the sample share similarities with other classes that probably were not properly labeled by VirusTotal. In conclusion, so our method demonstrated feasibility to classify Android malware based on the similarities, and also the threshold impacted the number of classes. As we can see in the table, is we vary the threshold, we are getting more or less classes. The method also demonstrates that similarities between the samples, and also we found that some of the samples share over 400 files that share at least 91% of similarities. And also we have proof that to cluster the sample based on the similarities and the threshold offers the possibility to find the subtypes. As I mentioned, is we vary the threshold from 91 to 100. We are finding the stronger similarity between those members. And that's pretty much it. So I think that I am on time.
Okay, thank you so much for your presentation, Horacio. It's very interesting. I would like to pass to the session to question and answer, please. If someone have a question, please open your microphone or within the chat, please. Okay, Horacio, thank you so much for your presentation. At the moment, we don't have a question for you. Thank you. I send you a virtual plus.
Thanks.
Yeah, thank you so much for everything for your presentation to this workshop. And we take 2 minutes to start with our closing to the workshop. Please don't leave to this room. Thank you.
Thank you, everyone, for being here and for reaching until this end. So it is very important for us to have you, all of you here, and thank you for your presentations. I hope you all enjoyed a lot and asked a lot, and the most important thing, learned a lot. So, well, this is something to say. Thank you to all of you, and please do not forget to write your reviews. It is very important to finish this process and in order to improve all our papers before sending them to the journal. For some cases, if you have any question, please let us know. Remember that our email is CCAIS2003, and you can please send it to us. So we wish you the best luck in the process of your publication. And well, thank you to all of you. Thank you very much. And please, we close and finish this workshop. Thank you. And sorry for the background. This is a meeting I cannot avoid. Thank you.
Listo.